In this experiment, we'll be controlling a servo motor using an ultrasonic sensor with Arduino. The ultrasonic sensor has 4 pins, out of which one is connected to the 5-volt input and the other is grounded. So the other 2 pins are the trigger pin and the echo pin, which is connected to the 12th and 11th digital pin of the Arduino. The servo motor has three pins, out of which one is the 5-volt and the other is the ground pin. The third pin is the signal pin, which is connected to the 9th digital pin of the Arduino. So we have a common ground and the 5-volt, which makes it easier to connect. So what we're doing in this experiment is we are transmitting a signal from the ultrasonic sensor and we are like placing an obstacle in between. So the signal transmits from the ultrasonic sensor and is received. This is used to calculate the distance of the ultrasonic sensor from the obstacle. So based on the distance, we are trying to control the servo motor. I'll be showing the code for the. So in this code, as you can see, we include servo.h. This library is used to do the math of the servo motor rotation. So we declare a servo motor named as motor and we set the trigger pin and echo pin to their respective values, that is 12 and 11. Then we declare distance and duration, which is used to calculate using the ultrasonic sensor. Now in the void setup, we begin the serial monitor using the serial.begin. Next, we attach the motor to the 9th digital pin of the Arduino. The pin mode is set as output for the trigger pin and input for the echo pin. In the void loop, as you can see, we have a function called ultrasonic. So in this loop, the ultrasonic, the digital write is set to high for trigger pin. So what the signal is sent from the digital pin of the ultrasonic sensor. There's a 10 microsecond delay and then the trigger pin is off, that is load. So what happens is a signal is sent from the ultrasonic sensor. After a 10 microsecond delay, it's turned off. So the duration is calculated by the echo pin. So that is when the signal leaves from the transmitter, hits the obstacle and is returned back and received by the receiver. So the receiver is received when echo pin is set as high. So this duration is then used in the distance formula. So the distance will be the speed into the time calculated. So the distance will be duration into speed of sound. The serial print is used to print the distance and it also includes the unit. So this ultrasonic is then used in the void loop. So what happens is next the motor write is set to 0. That is the motor is set to a 0 degree initial position. Next we create an if loop, that is if the distance is less than equal to 4, then the motor is moved towards 180 degree and after a 1000 millisecond delay it moves back to a 0 degrees and there's again a 1000 millisecond delay. So this loop continues until unless the obstacle is within 4 centimeters. So if it is greater than 4 centimeter, nothing happens. So this loop continues and I will be showing it now. So as you can see, there's nothing happening for the servo motor right now. And when I bring this closer, once the distance is less than 4 centimeter, the servo motor starts to rotate. We can see this behavior in the serial monitor. As you can see that now the distance is greater than 4 centimeter. And when I keep bringing the object closer, after it starts hitting 4 centimeter, the servo motor begins to rotate. It moves first to a 180 degree and then back to the 0.